Hello, ladies and gentlemen. Welcome to the wonderful world of Mishler math. And today we're going to talk about quadratic functions. Okay, a quadratic function. Well, first of all, we're going to define, identify, and graph quadratic functions, and we're going to multiply linear binomials to produce a quadratic function. What does all that mean? Well, first of all, let's multiply a couple of linear binomials and produce a quadratic function. So suppose f of x equals 2x minus 2, and g of x equals 2x plus 1. Well, f times g of x, we've already had this, and this is 2x minus 2 times 2x plus 1. And you guys remember, of course, the FOIL. When you're multiplying two binomials, you have to FOIL. You have to use a distributive property. That means the 2x has to be multiplied by 2x and 1. And the negative 2 has to be multiplied by 2x and 1. So we say the first 2 is 2x times 2x is 4x squared. And then the outer 2x times 1 is 2x. And the inner is a negative 2 times 2x, which is negative 4x. And the last is negative 2 times 1, which is negative 2. And you combine those, and you get 4x squared. The 2x and a negative 4x combined make negative 2x, okay, minus 2. Okay, that is our quadratic function. And a quadratic function is any function that can be written in the form f of x equals ax squared plus bx plus c. And a cannot equal 0, because if a equals 0, then of course you have a linear function. You have bx plus c. Okay, so f of x has to be ax squared plus bx plus c. And the one above, you probably noticed that a is equal to 4. b is equal to negative 2. c equals negative 2. Notice the negative sign sticks with whatever follows it. Get in the habit of making that negative sign stick to the thing that follows it, okay? And that'll save you a lot of grief, okay? So let's try a new one here, and let's say edit clear. And I want to show that the g represents a quadratic function, and I want to identify a, b, and c. So let's say g of x equals 2x minus 5 times x minus 2. Now, so the first thing is this a quadratic function? Well, let's multiply it out and see. Okay, 2x times x is 2x squared. 2x times negative 2 is negative 4x. Negative 5 times x is negative 5x. And negative 5 times negative 2 is negative 10, or positive 10, I'm sorry. Negative times a negative is a positive. So if I combine the like terms, I get 2x squared minus 9x plus 10. And so that, yes, it's a quadratic function because it is in the form f of x equals ax squared plus bx plus c. It's in that form. And also, a is equal to 2, b is equal to a negative 9, and c is equal to a positive 10. And so I've just shown that, yes, this is a quadratic function, and here's a, here's b, here's c. Now, you might kind of blow this off and say, well, who cares what a, b, and c are? Well, this is very, very important later on. So please get in the use of, or get in the habit of, get used to identifying a, b, and c. The other thing is what's the graph of a quadratic function look like? Okay, and now just a moment. I'm supposed to be erasing all of this. Let's see if I can do that. There we go. All right, so what's the graph of a quadratic function look like? Well, I always like to do this. This is a bola. Okay, and if I do this, I'm sorry, these are so ugly, then I have a parabola. parabola, okay? Bola, parabola. Maybe that'll help you remember a little bit. The thing I want you to remember is that every quadratic function has what we call a line of symmetry. The graph of every quadratic function has a line of symmetry. Okay, it's a vertical line that basically it's symmetrical. Every parabola is symmetrical. Okay, it looks exactly the same on the right as it does on the left. Now you're going to look at this and you're going to say, Mr. Mishler, that doesn't look the same on the right as it does on the left. That's because I'm a bad drawer. But a parabola, a real parabola, looks the same on the left. And the other thing is that you have what we call the vertex on a parabola. Okay, the vertex is either the maximum or minimum value. And let me change programs here, and I'll show you what I mean here. Okay, and so start with, here's a function, the graph of a function, and this one is right because the computer made it. Okay, so this is not a Mishler math made graph, this is a computer made graph, and it's correct. So f of x equals x squared minus 4x plus 7. All right, the quadratic function, okay, is f of x equals x squared minus 4x plus 7. The quadratic expression is x squared minus 4x plus 7. Please note, this is your function, this is your expression, okay? The quadratic expression. So, and please note that we found out that a equals 1, b equals negative 4, and c equals 7. So we just look at the coefficients on the x squared, the x, and the constant term. Now, the thing to remember here is you can have a quadratic function and b is equal to 0 and c is equal to 0. We just can't have a equal to 0 because then it's not a quadratic function. Okay. The other one is, let's take a look at this vertical line here that we talked about. You see that line? That's x equals 2. And that is a line of symmetry, x equals 2. Okay? And then finally we have this point. Point A is 2, 3. Okay? And that's your vertex, 2 and 3. Now, what is the domain of this function? Well, the domain is all real numbers because no matter what value I choose for x, I am certainly going to have a value, corresponding value for y. I can choose x equals 20. I can choose x equals 1 billion. And I'm still going to have a corresponding value for y. But take a look here. What is my y value at this vertex? If you look at the parabola, it goes up from here. It doesn't go down any. And so my range is x is greater than or equal, or excuse me, y is greater than or equal to 3. The range cannot go below 3. So y is greater than or equal to 3 is the range. And I can't write on this one, or I'd write that on there. But that's okay. And let's get rid of this one because this is just plain ugly. Okay. So let's do a couple other things here. Let's say we have f of x, and f of x equals x squared plus x minus 6. You say, well, okay, first of all, does this graph point upward or downward? Well, I'm going to use my graphing calculator for this because it's easy. And I'm just going to go to my y editor, clear, and push x squared plus x minus 6. And I'm going to go to zoom 6 with zoom standard because I always like to start with the standard graph and viewing window and see what that looks like. And for those of you who still don't know what I'm talking about when I say viewing window, okay, you notice that look at window, okay? Negative 10, positive 10. Those are my x maximum min values. If I change that to 20 or 2000 or anything, it's going to give me a bigger or a smaller picture of the coordinate plane. Okay, it's just how much of that coordinate plane I'm looking at, and I want to look at whatever part of the coordinate plane shows me the graph I'm looking for. Okay, so here's f of x equals x squared plus x minus 6. As you can see, it points upward. Okay, so we'll just write that in there. It points up. Okay, and also we want to know what's the vertex of that graph, approximate, or actually you can get it exact just using the calculator. And it's pretty easy, and I'll show you how. You hit second. See a little window here? It says I'm on the second tier of things here, and I go up here above trace. It says calc, and you see where it says maximum right there, or minimum. Number 3 is minimum, 4 is maximum. Since my graph points upward, I'm looking for number 3, minimum. So I hit enter, and you notice what it says left boundary. So I'm going to look for a minimum at a certain place, because we end up with graphs that do all kinds of weird things, and it might have I might have a goofy looking function on there that has more than one max or minimum. So let's see if I can find my left boundary, enter, and then go to the right, and you see that little arrow up here? That's my left boundary. That's I'm going to look in between those two arrows, and so over here I set right boundary and I put an X there. And you see these two arrows pointing inward up here? It's going to look in between those two for my minimum point. So if those are not wrong, if you get the left and right boundaries incorrect, you get an incorrect answer. So anyway, I hit enter, and that shows, it says negative 0.5 and negative 6.25. But you see there's a 6 over here. You get a little bit of rounding error on the graph, okay? So we're just going to say that the minimum is negative 5 and negative 6.25. So let's write that in there. Minimum is negative 5, or negative 0.5, and negative 6.25. Okay? And graph that, and look at the graph of that, and sure enough, that looks like that's my minimum right there. Okay, so let's take a look at another one real quick. And okay, now we got another function here, and it says f of x equals 5 plus 4x minus x squared. So let's put that in our graph here, and clear 5 plus 4x minus x squared. Now what do you think this graph is going to do? Some of you probably figured this out already. Take a look at the graph, and you see it points downward. Okay, and so we write that in there, the graph, it points down. Okay, or opens down. You say it opens down, downward. Okay, so it opens downward, which means I'm going to have a max. Okay, I'm going to have a maximum value, not a minimum value. So the max, and I can use the same function on the calculator and find that maximum value. And I'm going to go through this kind of quickly. So calc, maximum, this time it's number 4. And I can left boundary, I can make the left boundary where it is. And go over here and click, 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 click. Right boundary, enter. And it's going to look for a max between those 2 points, enter. And my maximum, it goes, again, a little bit of rounding error, so I'm just going to call it 2 and 9, okay? So the max is 2 and 9, so 2 comma 9, okay? What did you notice now about A, B, and C? So for the first one, A equals 1, B equals 1, C equals negative 6. For the second one, A equals negative 1, because look, my x squared is a negative x squared, so A equals negative 1, B equals 4, and C equals 5, because these are lined up backwards, okay? So A is negative 1. So basically, it should be obvious at this point to you guys that if A is positive, then it points up. If A is negative, it points down. That's all I got for you today. Thank you very much.